Hi everyone, apology it's been a while since I've done a video. I've had a issue with internet connection, but thank God engineer came around on Monday and sorted it for me. So I'm finally back to a decent internet connection. So I thought I'd do this video. Goes back to the age-old argument of iron meters versus multimeters and which one's more accurate, yada yada yada. There's one fundamental flaw that the people that believe that iron meters are better than a digital multimeter in the terms of pulse motors. Probably going to be best for me to just show you rather than explaining first of all. So if you have a look at the back of this thing, you can see the terminals there. No wires connected at all. Now, well, first of all, let's shove this close to the webcam. It's a 10 amp meter and the needle is around about 0 amps, more or less, maybe. I'm going to say the first issue with one of these analog meters is inaccuracy. Doesn't pick up, well, you can't tell accurately how many milliamps, certainly on that scale, that it's drawing. But there's one other fundamental flaw with them, and so it's specific to pulse motors. Oh lucky, I'm drawing, what's that, 2 amps? Oh wait, no, I'm generating power. Way! I've got over unity. Woohoo! Yeah. Okay. Huge problem. Yep. Watch this. It's not even near it. That's like right at the edge of my desk. So I rotate it round so it's pointing at it. Don't forget, this is a very weak magnet. And the field from it is extending. Have I got a ruler around here? No, bugger. 20 centimetres is a rough guess. Okay, let's try something smaller, shall we? Neodymium magnet. Needs to be a little bit closer, that one does. It's probably 10 centimetres, 4 inches. I'm just rotating it round through the poles. It's also a perfect indication of how far your magnetic fields extend from the magnet as well. So don't forget, that's only a small neodymium. Say 10 by 20 by 5. That one is, and it's only N42. But as you can see, even at 4 inches, it gives quite an effect on that meter. If we take something like, oops, try not to drop everything on the floor. Take something like a stack of these things, which are circular magnets. Yeah, they have an impressive field on them, as you can see. I put them on the edge of the desk, you still can't see. So, what most people don't get with an analogue meter like that is that they are affected by stray magnetic fields. We already know that we get EM radiation from a pulse motor. That's evident on quite a few of my videos. I believe one or two other people have had the same sort of issues. So, which is more accurate? Truth be told, they both have inaccuracies, basically. To the best of my knowledge, there is not a 100% accurate way of measuring input and output. Not in terms of pulse motors. Or, well, yeah, pretty much. I mean, a DC motor does pulse. An AC motor, you've got the issue of AC sine waves and calculating the current, which is basically what happens when you measure the current from an AC sine wave. So, the argument for and against either method basically should not be used as an absolute. It should not be used as evidence that a motor is over unity or not, because multimeters can show plus or minus the results. So even if your pulse motor shows, say, 99.9% efficiency, well, there's always a chance that it could actually be unity or slightly over unity, as well as being drastically under 99%. That being said, as long as you're using them as an advisory, or an indication, I should say, then there's no issues. Proving a device is over unity, unity or over unity, is a subject that is extremely complicated, and well, it can be argued that only a closed loop system can be proved to be over unity. I generally tend to agree with that one. However, what most people seem to miss is that if you're running a pulse motor that draws, say, I don't know, 50 milliamps, 100 milliamps from a 12 volt battery, if that 12 volt battery is a 100 amp big beastie, then it can benefit the system in terms of efficiency, but it's also going to take days, weeks, if not months, to actually run the battery down to a point where you can actually measurably prove to say, yes, this is under unity, or no, this is over unity. So there kind of is no definitive guide. That being said, some of us have gone into a lot of, used up a lot of time to attempt to explain and put down guide rules, etc. So thought I'd leave that one with you. I will say the downside of multimeters, as a general rule, they only sample something like 4 or 5 times per second, which basically leaves a whole big gap between samples where quite literally anything can happen and the results aren't affected. So if you're measuring current, then in between the samples you can get a huge surge that the multimeter would not show. Likewise, if you're measuring voltage, you can get spikes in the voltage that the multimeter would never pick up. Now, you can rapidly scan voltages and currents, but obviously the faster you scan, the more information you pick up, and again you've got the age-old problem of displaying that information. Averages will only do so much. Knowing the peaks and the troughs, well, that gets you a bit further. So bear that in mind, that all meters, analog, digital and other, are an advisory. Now, that being said, an oscilloscope, even the cheap ones that are around about 10 megahertz, they will pick up quite a bit, and the more expensive ones that run like 40-50 megahertz, they pick up even more. But the issue there is they're only designed for voltages, and even if you zoom in quite a fair way on the signal, there's only a certain accuracy that you can get. So there'll always be some sort of inaccuracy. And not only that, it's not exactly easy for the human eye and the human brain to perceive all of the information being displayed. So just bear that in mind, and be careful when making claims. Talk to you later.